Let me start with SLA, some introduction, some background about SLA, the place where I work in, Singapore Land Authority. We have a vision, limited land, unlimited space. This is really about us managing a small city-state, limited land, but we are actually looking at how do we manage the unlimited space. So in this case, we are talking about space to be created above the surface as well as below the surface. SLA has three pillars. I think one of the main pillars is really looking into geospatial information, how to use geospatial information, and how to improve the lives of citizens using geospatial information. So the main motivation for our work is really about digital twin. We all know that digital twin underpins the city of tomorrow's. It is an important component from the perspective of a digital economy. From a Singapore perspective, we have this framework that has started and is a progressive framework that would allow us to build digital twin that would support our smart nation, as well as part of the digital twin will cover underground in 3D. In this case, we are talking about 3D geology data sets as well as 3D underground asset data sets. So the digital twin program is actually underpinned by the National 3D Mapping Program, which we started in 2014 to extensively capture 3D mapping data. In this case, we are talking about imagery and laser scanning point cloud above ground. So it is comparatively or relatively easy to do this above ground. However, we also need to look at underground together with what is above ground in 3 dimensions. So the 3D mapping program that would help us produce the digital twin is an important element. The data, the products produced, supporting the sustainable, resilient, and smart Singapore in these 6 areas: the security and safety, the infrastructure development, the urban planning, the resource management, risk, environmental risk, as well as smart mission. So the amount of data, in this case, 3D mapping data and products captured and produced, has been shared across the government agency, used extensively in the different applications, and become the bedrock for the different applications among the government agencies. And of course, we are looking at this digital twin going underground. So the above ground relatively is the easier part, but what about underground? How do we go about in ensuring that we can continuously capture and manage reliable underground data? In this case, we would like to focus on utility information that covers the shallow part of the underground. And progressively, we would also want to work into other types of underground data, which comparatively may be easier compared to the utility information. The need for a reliable map of subsurface utility in Singapore. We have started to build many types of activities underground. So this is a diagram that is quite common in Singapore, that we are putting many of our activities underground to save up the space of above ground for the better living of our citizens. So a lot of the activities goes underground. I think many of the utilities, the traditional utilities as well as the new type of utilities, would go underground almost 100%. The transportation, a lot of them goes underground, as well. Some storage, waste disposal also go underground. As this development progress, I think the whole logical idea is really reliable 3D data of underground become more and more important. It is not just about having the data or the 3D data. In this case, because of the overlapping condition, because of the connection to the above ground, we really need to look at the accuracy of the data, the reliability of the data, the updatedness of the data underground, to ensure that there is a sustainable system or ecosystem that would allow us to move forward with this development. So we know that the reliable information would lead to better decision and save resources. These are the motivation for us to push forward this initiative. From a perspective of planning and land administration, the reliable data would help us a lot in this area. From the perspective of infrastructure development, elimination of uncertainty and risk during planning and design. This would save a lot of costs, save a lot of repetitive work. In terms of construction as well, we have a very congested city. So with a good data, it will minimize repeated work. It will minimize disruption to environment and services. And of course, at the end of the day, it will increase safety in terms of the people working in the environment as well as the general public in general. So in our project, we also look into how reliable are the existing data, and then we concluded that the utility data in Singapore generally are still in 2D. The data quality is insufficient. Data is often low, in terms of location is inaccurate. A lot of the time are not up to date and also incomplete. And also we found out that the data quality is also undefined. So we do not know which piece of data is of higher quality and which piece of data is really something that we can't use. Is approximation. So the data quality is largely unknown and the technique of measure is also undefined. So these are the very fundamental survey and mapping issues that we are looking at as a cause of where we are today, and the roadmap that we are looking at, the vision that we are looking at is really to be able to tackle these issues. So when you have unreliable data, undefined quality, it's a repeated pain. Every project you need to really find out what is underground. It is slow, long and costly planning in terms of design and development of infrastructure. A lot of repeated work required, and of course create nuisance and sometimes incidents and disruptions to the general public. We really want to seek to solve this problem in a sustainable way and in long term, right? And of course, I think we all understand that we can't really do this overnight. So the Digital Underground Initiative started in 2017, around end of 2017, 2018, with a phase 1 completed in 2019, and then phase 2 started in 2019 and completed in 2021. The objective is really towards developing a reliable map of subsurface utility in Singapore for planning and land administration. So it's a very simple and clear objective that we have set for the Digital Underground project, focusing on utility to start off with. And we have a long-term vision, 4 phases. First phase, which we have completed, phase 1, we call it the roadmap phase, where we look at the current situation, find out what's the problem, create a roadmap. I'll go into the detail later on. Second phase is really to do a bit more than the roadmap, look into the foundation of a utility mapping ecosystem, what are requires, propose those components. And now we are in our third phase. We are looking at the workflow because we believe that there are many components that will contribute towards the reliable data. And of course, all the work that we are doing would be gearing ourselves towards the operational phase, which is the last phase after we finish our third phase. So the question that we ask ourselves, what is reliable data? What is reliable utility map of underground? There are 4 characteristics. We are looking at accuracy, updatedness, complete. We know that is utility data is in a network form. How complete they are is important, and consistency. I think these are the 4 major characteristics. And the enablers, to achieve this, we are looking at these 6 components. The governance, we believe that technology plays an important role. Industry, I think I will elaborate more later on of these components. The people as well as the capacity. And of course, we really believe that workflow is important. Workflow in capturing and managing these data sets all the way to the usage of the data set. And in today's context, we are talking about digital data. IT systems is important for us. So we have different programs that look into the 6 components. And in our first phase of our work in road mapping, we actually came out with this national mapping strategy for the subsurface utility. Firstly, the newly built utilities, we want to ensure that new data that get into the database, we need to ensure that they are reliable, they are good, and we have certain strategy to ensure that. We wanted to look at opportunities, that when there is a chance for us to improve the quality of existing infrastructure below the ground, there is a way for us to do that. And we need to look at technologies, the scanning technologies that would help us to improve the quality of existing data. And there is a strong, I think, part of the utility strategies, the national mapping strategies, is to look at quality control. And we try to be having this quality control at the front end, not at the tail end of the information supply chain. So this is articulated clearly, and we try to use this as the guidance for us to move forward. And there were 5 components identified as the integrated approach towards the utility mapping ecosystem. So we call this the 5C. The first one is coordination. We believe that there is a need of coordination from the agency's perspective. We also believe the second component, which is the consolidation. When data sets are not consolidated, it is very hard for us to ensure the quality. So consolidation is important aspect of the reliability that we want. The other C is about capture. The new technologies, the traditional technologies of surveying, all these are considered as long as we are able to capture the data with the accuracy that we want. The fourth C is capacity. We know that we need people who are able to do the work. So capacity building is a key element in this approach, this mapping ecosystem. Last but not least, community. I think later on I'll also talk about that a bit more, where we need buy-in, right? Because utility mapping is not a new industry. It has been there for many years. There is a community. We need to change the mindset of the community about why quality data is important, about why you need to invest upfront, and you will get the benefit in the long run. So we need to engage the community and to get a good buy-in from everyone. The next segment of my presentation will cover some of the activities, some of the work that we have been doing. One of them is really to look into the mapping techniques, the technologies. We have been looking at the different new technologies that will allow us to capture the utilities information, the different types of ground penetration radar, as well as gyroscopic method, and we are looking at this in a technical way, and we would like to capture all this as part of the standards that would be allowed to capture information of utilities in Singapore. In the first phase of our work, we actually carry out a case study to look at the 3D GPL mobile mapping systems, pilot a work in Singapore's street, trying to understand that technology, how effective they are in our work, and this is what we have done way back in 2018, together with the Singapore ETH Center's researcher, capturing the data and putting them in a 3D environment that we are building. So this is another slide that shows that after the street capturing, when the data are processed and when the data are plotted into a GIS, the blue lines are the utilities that we are able to capture. More data. These are the tomography scan information that has been captured using the the GPR systems that we have tested earlier. And there is a team that looks into the 3D modeling of those data that we have captured, and then visualization, part of the work that we are looking at. Another area, so those are the part that we are looking into technology, using GPR technology to update and to capture reliable data of underground. The other portion of what we are looking at really is the governance, looking at data capture responsibility, data quality improvement responsibility, data quality management responsibility, and of course, looking at SLA's role. We wanted to introduce a new framework so that we can ensure the data reliability and data quality of this utility data going into future. Singapore Land Authority, progressively working out a new role to ensure that we are able to move into the new workflow. So I will share a bit more about the workflow later on. One important bedrock in this work to ensure the quality is really about the standards and specification for utility survey. So we started these standards in 2017, and the standards basically is a living document. When we started, we are focusing on the newly installed as-built datasets, for the 6 types of utility that we have in Singapore. Moving on, we focus on a few other areas, trial trench utility survey. So it covers how you do trial trench utility surveys, as well as moving forward, we are looking at a more modern, unique type of utilities underground. These are some of the new utilities that we have in Singapore. One of them is known as the pneumatic waste conveyance system pipes. So this is a utility that that is used for waste management in Singapore. The new town in Singapore are installed with this kind of system underground, and the standards of the utility survey would cover this area going in the future. And of course, the standards, the development doesn't stop there. It is a living document, and we are looking at several ways of improvement of the survey standard. So it's ongoing work, looking at the roles and responsibility in details of the surveyors, of the person that is submitting the data, and then additional scenarios for utility surveying. So the different ways of doing it. So trenchless utility survey, utility installation is one of the area that we are currently looking into. Additional mapping techniques, gyro and GPR are 2 areas that we are looking into. Again, utility types, new utility types, district cooling system pipes is a new one that the team has to start working on it. Looking at data quality again, and of course the standards for submission of the format. So of course, with technology, we are exploring new workflow of capturing data and new types of data. And in this case, it's not just the vector data. We are looking at 3D models. So this is one trial that we have done in Singapore. What it captures are point clouds data in 3D of a trial trench. This actually modernized the way we capture data and we store this data in the database. So all these 3D information are measurable and traceable, so you can actually see the pipes in very large scale. And with a proper way of storing the data and integration it into GIS, imagine that all this information are very good information that once you open up the trench, you can see what's inside, and you can share this information with the other person, who comes along, and they really don't have to open up the trench anymore. So, and this data set also, when they are 3D, we are also working on the different visualization and even the visualization on site with AR technology are enabled to provide a good service to the user on the ground. Moving on, we are actually working on the 3rd phase of our digital underground project towards implementation of data capture workflow. So we had the roadmap, we know about the component. Currently, we are working on a pilot project, trying to work with the industry, with the asset owner, with the professionals, and trying out all the components that we are talking about in a workflow manner. This is still an ongoing work in our department. So traditionally, I think a lot of places we know that the utility data are captured in silo. So the different types of utility, the water, the telco are captured separately, and usually these data sets are only integrated or combined at the end of the chain, right, at the warehouse part, and is shared out. And often we know that the data sets are very difficult to integrate at that time. So in terms of the workflow, we are actually suggesting a new workflow that would not interrupt or change the current workflow so much, but a new layer on top of the current workflow. So the asset owner, the different asset owner will still continue to do their work. But on top of that, we are requiring a submission to SLA as the guardians of the data quality in the data quality hub to ensure that the data that has been captured in the field are quality control. And this data will be feedback to the asset owner. So through this new layer on top, we really hope that the data quality can be checked upstream. The data standards should be complied to, and eventually will ensure that the end result, we are getting the reliable and high quality data that can be shared back again to the user and to the planners as well as to land administrators. So,
hi, Victor, you've only got one more minute.
Yes, so I am coming to the end. So this is the desired outcome of what we are looking at. There's a component of the as-built survey records. We are also looking at the legacy records using different technology to improve the quality, as well as the new data and the proposed data will come into the same database to help us ensure that we have a quality and reliable data going in the future. Again, another way of showing it, the 5 Cs and the many components in the ecosystem that we are trying to build going into the future. As I said, I think the community is important. We need to have a lot of buy-in. So the Digital Underground Connect is a platform where we provide people to meet, to learn, and to improve. I would end my presentation with a short video that summarizes what we are doing. Thank you, everyone.
So Victor, I'm just going to read a couple of the questions out. First question, Victor, you have identified many use cases for information about underground infrastructure. I expect it will be difficult to address all of these simultaneously. Have you prioritized your use cases?
In fact, in our work, we are looking at very high level use cases instead of looking at the specific use cases. So in our case, we said that we are supporting the urban planning usage. In fact, the project actually is driven by the need in planning underground. In Singapore, we have started to look at master planning of underground space. And when the authorities started to look at this, we realized that you need consistent data set, you need reliable data set, you need 3D in order for us to do that well. And also from the land administration perspective, these are the driver for us to go for reliable data set. And we know that when we can achieve good data set, high quality data set, the rest of the applications are really, it's just a bonus for us. I think other part of the world really are looking at more operational use cases, but in our case, the drivers are really the urban planning and the land administration.
Another question, does the measurement of objects meet civic engineering standards? Follow up to that, are the ISO standards that your data must comply with for environmental assessments and other asset management frameworks?
The idea that we have is really, it is going into engineering standards, very high level. We require surveyors to capture all these data on site. And that is a starting point. The challenge for us is, of course, the process is very challenging. For every work, you require surveyors to be on site. So to start off with, our standards are geared towards that. We are actually looking at some other ways using photogrammetric methods, videographic methods to look at capturing data. So the relative accuracy would still be very high. Absolute accuracy is another area that we are looking at, because that's where the challenges would be in order for us to capture all these good quality data.
Thank you very much, Victor.
Thank you for having me.